Now in this video, I'm going to show you guys how to do the chain rule a bit differently. So let's start out with an example. F of x equals sine of x squared plus x plus 1. Cool. So now the idea is the following. Think of a drill. So I'm drilling a piece of, I'm drilling through slabs of walls. So now it's one wall, two walls, three walls, four walls, and five walls, right? So the idea is we first hit that wall, cool, then we drill through this wall, drill through that wall, drill through that wall, and drill through that wall. And then we're essentially going to be done. Okay, cool. So now first things first, again, I have a drill. So the first function that I hit, it's the sine function. So I'm going to let A equal sine. But we don't care about this from now. What I mean by that, it's the inside. We're just going to call it B. Cool. Then we're going to drill again. So now I'm hitting the inside of here, which is x squared plus x plus 1. And I'm going to let that be called B. So B equals this inside x squared plus x plus 1. And the whole reason why we do that is because the derivative of f, it's going to be f prime times a prime times b prime. Okay. So let's find the derivative of a. The derivative of a, which is a prime, it's equal to the derivative of sine b, right? So derivative of sine b, it's what? Cosine b. And the derivative of b is just going to be 2x plus 1. Great. So now recalling that f prime, it's going to be a prime times b prime. All I have to do now is just replace a prime and b prime with what we have on the right hand column. Okay, with that, it's going to be cosine of b times 2x plus 1. Cool. Now we're kind of done, but not really. The issue here, if you guys can spot it, is that initially our variable was x, but here we have b. Cool. So in other words, we have to replace the b with the x's, i.e., going back to the original derivative, and that's okay because on the left hand side, sorry, we have a equals sine of b, b equals x squared plus x plus 1. And what we do now is, hey, here's b here. So b is going to be equal to x squared plus x plus 1. Fine. So now I'm going to replace what b is. It's just x squared plus x plus 1 times 2x plus 1. And just for a bit of cleanup, I'm going to write it right next to each other now. So times 2x plus 1. Great, we found the derivative of f. Cool. And the reason why I wrote it like this, it's because when the problem gets longer, more complicated, it allows us to keep track of the derivatives. This is like a prime times what? B prime. Okay, so let's see a more complicated example. Okay, so this problem here, it's a bit more complicated. So again, think of our drill. The first function that we hit, it's sine. So remember when we started a equals sine, but I don't care about this. So I'm just going to call it b. Great. So taking my drill again, the next function I hit is the cosine function. So I'm going to say b equals cosine, and I don't care about this. So I'm going to call it c. And finally, the last function that my drill hits, it's this guy. So now it's going to be c equals x squared plus x plus 1. And again, the derivative of f prime, it's going to be a prime times b prime times c prime. So doing that on the side, a prime is just going to be cosine b, the derivative of sine b. And if my b equals cosine c, then the derivative of cosine, it's going to be negative sine, and it's a c, so it's going to be sine c. Then the derivative of c, we differentiate each term, so we're going to get x squared, sorry, not x squared, 2x plus 1. Cool. And piecing this together, I have cosine of b times negative sine c times 2x plus 1. But again, there is a problem. I have b's and c's, but the original variable was x. That means that I have to go back to this column and plug in and then replace the variables until we get back x. All right, fine. So let's do that now. Cosine of b, remember b is here. So to get b, I just go down. So that's going to be cosine of c. But remember c, it's all of this down here. So I'm going to replace c and I'm going to call it x squared plus x plus 1. Cool. Now to replace the c and the sine and the negative sine c part, again, what's c? C, it's here. So c, it's going to be this whole thing. It's going to be x squared plus x plus what? Plus 1. Great. Cool. And then finally, and this one is fine. So let's just write 2x plus 1. And again, doing a bit of cleanup. It's going to be cosine x squared plus x plus 1 times, there's a negative there, so I'm just going to pull it to the front. Sine of x squared plus x plus 1 times 2x plus 1. Great. Okay, so now let's do a more complicated problem. All right, so here's a more complicated problem. Notice that there's 1, 2, 3, 4, and 5 functions. It's composed of 5 functions. Cool. And for those of you who are watching the video, it's kind of like, hey, why the hell is he not using like the onion method that we learned in class? The truth is that the onion method, it's cool. It's essentially the same thing. The issue with the onion method is that for more complicated problems such as this one, it gets hard. It becomes difficult to keep track of all the derivatives. So this way, it allows you a way to pretty much keep track of all the derivatives that you do, and it also allows you to get partial credit on a test, because when you do the onion method, I don't know what the hell it is you're multiplying. So in order to award you partial credit on a test, we have to show more work, right? So the more work you show, the more credit you typically get. So this is the idea. And also for something called partial differential equations, this is the upper division university mathematics class. It's like ODEs, but a bit different, and I'll explain why in a bit. Is that here, typically for PDE, that's what it's called, the first step is typically the chain rule. And in my experience, I noticed that many students taking PDEs, they still have problems applying the chain rule. And the reason why, it's because the functions become more complicated, and you just don't have a function of one variable. You can have a function of many variables, and students, for the most part, they don't know the chain rule. So using the method that I'm showing you, it translates well to even more advanced math classes. But anyways, like, enough of my rambling. Just telling you guys why we care. So now let's attempt this problem. Cool. So now again, I have a drill, so I'm drilling, and remember the first thing that I hit, it's not tangent, so we always call the first one A, right? It's not tangent, but it's the outside function, which is the cubic function. So the cubic function here, we're going to call it A, and we don't care about this because it's too complicated, so we're going to just call it a B. So it's going to be B cubed. Okay, cool. Now taking my drill again, the next function I hit is now the tangent function, but this guy here, this whole thing, it's too complicated, so I'm just gonna call it C. So now the next function I hit, it's now the sine function, so C, it's gonna be sine of this. That's too complicated, so I'm gonna call it D. Okay, and then my next function that I hit, it's gonna be the exponential function, which is E. So I'm gonna call it D equals E. But this is kind of complicated, so I'm going to call that let's call that G, because I already use E, I already use F. And we usually don't like to use e as a variable because e, it's a number like pi. It's a constant. It's, like pi, so I usually not use e. Anyhow, and f, it's the name of the function, so that's why we call it g. All right, cool. And then g is equals like e equals like just ln function, but this is kind of complex, so I'm gonna call it ln of let's just, hey, what the heck, let's just call it r. And then r, it's gonna be or 0 r now, it's gonna be x squared. Cool. And check this out, the derivative in this case is gonna be it's gonna be a prime, b prime, c prime, d prime, g prime, and r prime. That's very long, but just because it's long, it doesn't mean that it's difficult. So let's do derivative a. Derivative a prime, it's going to be 3b squared. Take the derivative of b. My b equals tangent of c. So derivative of tangent, we know that it's secant squared of c. All right, cool. What's the derivative of sine? Oh, again, it's with cosine d. Then the derivative of d, which is the exponential function e. D, it's going to be d prime. It's going to be eg. Then the derivative of the logarithm of just a lateral log, g prime, it's going to be 1 over r. And the derivative of r is just going to be 2x. Cool. So now I'm going to now I'm just going to multiply all the derivatives together. 3b squared, and remember to write them like a diagonal. So the first one is 3b squared, the second one is c squared c, the next one is cosine d, the next one is e g, the next one it's 1r, and the next one's going to be 2x. Cool. But again, there is a problem because I don't have the original variables. I have b, c's, d, g's, and r's. But the original problem was given x, so I have to go back to the left-hand column and plug them back in until I get all x's for variables. And that's easy. So again, the first one, 3, and then remember b, it's here. So I hit tangent, so I get tan, but in a tan of c, but remember c is here, so I go sine, and then the sine, and d is here, and this is going to be d, so it's going to be e of g, but remember g, it's what, this here, so it's going to be n of r, but remember r, it's what, that guy there. So I get this, and I want you guys to be careful because notice that we have a squared, and the square is the top of the tan, so we could just put it here. Cool. So now going down to the next one, which is secant squared of c. You have secant squared, and remember c, it's here. Okay, so now I hit sine, and then from sine of d, it's what? Eg. But remember, g, it's what? Ln of r. But remember, r, it's what? X squared. X squared. All right, cool. And then for the next one, which is going to be cosine of d. But remember, d, it's here. So d, it's equal to e of g. But remember, the g, it's equal to ln of r. But remember, the r is equal to what? X squared. Cool. Then for the e of g, remember, g, it's equal to ln of r. But remember, r, it's equal to what? X squared. Cool. And then for the 1 over r, remember, r, going back to the left, r is just what? X squared. So replace it, and finally times what? 2x. So now we could leave it like this, but it looks kind of weird, so let's put it all in order. So this would be 3 tan squared of sine e ln of x squared. It's kind of hard sometimes just to keep track of the parentheses because they're nested functions. There's a lot of them. So hopefully I didn't make a mistake writing this out. And notice that here I have x squared and 2x, and they're multiplying, so I could simplify. So I'm gonna cancel that out, and that's just a 2. So I could just write it right here. I could also multiply the 3 and the 6, sorry, the 3 and the 2 together, which gives me 6. And to make it a bit neater, I could just divide everything out by x. So let's do that. So I'm gonna get 6 over x, and I could also cancel these out here, right? Property of logs, but let's just leave it like that. So this would be your answer for this very, very complicated function. And for those of you who looked at the video or like, well, this is nonsense, it looks more complicated than it is, try to do this problem using the quote-unquote onion method, and let's see if you get the correct answer, and let's see how long it takes you. And surprisingly, if you practice this method is actually pretty fast. It just looks like it takes a long time, but that's because I'm demonstrating it to you. But you do this for a bit, you get the practice of it, it's fast, and you would never ever get the chain rule wrong. And in the event that you do get it wrong, you get more partial credit doing it this way than you would do doing the like just the onion method, because the onion method uses quote unquote mental math, and the teacher doesn't know what you're thinking. So use this method instead. All right. I could do some more, but I think you have the idea. I would leave you guys some challenge problems in case you want to attempt it. So I'll write down the challenge problems for you. Okay, and here are the challenge problems as promised. I want to mention something real quick for the last one, this one here. This does require students to know what the fundamental theorem of calculus is, which is typically covered almost at the ending of calculus 1. So for those of you who so ideally this problem here would be for students who are like already reviewing calculus 1 in preparation for cal 2, or for those of you studying for your for like for a final. So if you haven't learned the fundamental theorem of calculus, then this last problem, just skip it. Okay, like as always, thank you for viewing, and please like, subscribe, and share. And thank you for your time.